Now we'll see what is thrashing. It is very important topic in operating system. So thrashing is linked with degree of multiprogramming. How many processes are present in main memory is called degree of multiprogramming. CPU utilization increases if maximum processes are present in main memory. Due to the finite size of main memory, we cannot bring all the processes in main memory. I have already discussed this, right? The secondary memory size is very big and main memory size is very small. Okay, so it's a finite size. So we cannot bring all the processes from secondary memory to main memory. Suppose there are three processes in main memory. For example, we are taking three processes P1, P2 and P3 in main memory. Okay, so whenever process demands any IO operation, for example, P1 wants some IO operation. What is IO operation? Maybe the access to the printer or joystick or maybe mic or speaker. Okay, so what will happen? The process goes into block state. Okay, the process will go to the block state and hence CPU becomes idle. Therefore, throughput will decrease, reducing the performance of the system. For the maximum utilization of CPU, maximum processes should be present in main memory. As the size of RAM is finite or limited, we cannot bring entire processes in RAM. Hence, we use concept of paging. Degree of multiprogramming will be maximum when we can bring one page of each process in main memory. Okay, so all processes will be in main memory, only part of the process will be in main memory, not the entire process. Okay. So if CPU wants page 1 of process 1, okay, I will draw this now. Suppose there are 100 processes in main memory. Okay, P1, P2 and so on, P100. Okay, so page 1 of P100 or page 1 of P2, page 1 of P1, okay, maybe page 1 of P3 and so on. Okay, so if CPU wants page 1, okay, if CPU wants page 1 of process 1 and page 1 of process 2 and page 1 of process 3 and page 1 of process 100, then there is no problem, right? Because all the pages are present in main memory. But if CPU wants page 2 of process 1, then page fault will occur, right? Because it is not present here. Whenever page fault occurs, we use page fault service time that we have seen in the last lecture. Means the page is brought from secondary memory to main memory and which takes large time. Same thing will happen if CPU demands for page 2 of other processes. So it may happen that we achieve degree of multiprogramming by bringing one page of all processes in main memory but unable to complete the demand of CPU. So operating system will take large time to bring pages from secondary memory to main memory, which will degrade the performance of the system. So this we can show using this plot. Okay, first I'll draw the plot. So what is there on x-axis? Degree of multiprogramming versus CPU utilization. Okay, so the curve is like this. So maximum point here, I'll name this as A, this is B, okay, and okay, this is called as thrashing. So initially what happens? Initially, even though few processes ask for I/O operations, CPU won't be in idle state as there are many other processes in main memory which are in ready state and can be brought in running state by CPU. Hence, CPU utilization will maximum here. So here initially the CPU utilization will be maximum till point A. Why? Because there are many processes which are available in ready state in CPU which can brought into running state. Okay, so at point A, CPU utilization is maximum for a particular point of degree of multiprogramming. Okay, for point B, this point this is maximum, right? CPU utilization is maximum. After A, page fault will start increasing. Okay, so the match is not found, the page fault will increase, decreasing the hit ratio, reducing CPU utilization. So this is called as thrashing. So what is the solution for this? First thing what we can do is we can increase the size of main memory. Okay, but this is not very easy on regular basis. It is expensive. The memory is expensive, so we cannot increase this. Okay, second solution is we can use long-term scheduler. So the what it does, the responsibility of long-term scheduler is to bring maximum processes in main memory. Okay, so by reducing the speed, degree of multiprogramming can be controlled, but we should not allow to go beyond point B in the figure. Okay, so that is the main thing, that if you stop here only, okay, then this phenomena will not exist. Okay, so we should try not to go beyond point B in the figure.